Hello, my name is Isma Kuriga. I'm a PhD student at the Institute of Archaeology in Nikolaus Copernicus University in Tallinn. On behalf of the co-authors, I want to show you a quick presentation titled Let's Build Something Big, a few words about Open Air Museum of the Institute of Archaeology Nikolaus Copernicus University in Poland. In 2014, the Institute of Archaeology of the Nikolaus Copernicus University in Tallinn acquired funds from the Ministry of Science and Higher Education for the implementation of a program called Reconstructing of the Cabinet of Artifacts. The project was in line with the tendency to intensify disciplinary research and the need to create and implement new ways of deepening knowledge about the human past. As a part of reconstructing activities, a section of the area surrounding the Institute of Archaeology was arranged for an open-air archaeological museum with reconstructions of buildings, residential and economic functions, along with infrastructure as well as places of burial and worship. In the museum, a Mesolithic shelter was the first building that was constructed. It was built by members of the Society for Prehistoric Experimental Archaeology. This shelter was intended to be a full-size reconstruction with a regular base 5 by 4 meters with rounded sides. Such dimensions are characteristic for flint skaters, interpreted as the remains of Mesolithic dwelling structures. During the whole process of building the shelter, we used only techniques and tools that were known in the Stone Age. We used replicas of implements such as deer antler diggers or antler adzes, which were used in Mesolithic, and we know them from many archaeological sites in Poland. The thatch was made of dry reed cut with the use of 3 types of sickles with flint ends. Dig a 30-centimeter deep foundation trench. Then the pegs with a length of 1 meter made of golden rose and black locust were put inside and secured with stones. They were the base of framework on which the wattle was constructed. Another step in the shelter construction process was the preparation of the roof framework. The framework was laid on support arches and a series of semicircular rafters, giving the entire structure shape of a dome. All structural elements were tied to each other with the use of vibram and black locust brass fibers, as well as willow rods collected on the site with the use of flint tools. The process of constructing the thatch starting with placing rods onto the roof framework to provide support for the thatch. For that purpose, sticks were used, fastened around at 9 levels, each 30 to 40 centimeters up from the level below, covering the shelter frame. The laying of thatch started from the ground level by pressing a 5 to 10 centimeters thick layer of reed with sticks covering the second series of framework rods around the structure. The reed was placed very tightly, and the 2 rows of sticks were fastened to the rods every 30 centimeters. The lower part of thatch was placed on the first series rods, and the upper one was pressed with the use of another layer of sticks around the structure, situated about 50 centimeters above the lower level. Another layer of thatch was secured to this layer. This was repaired 7 times, thus forming 7 layers of the step-like thatch. And here you can see the final result of our work. According to calculations, covering the entire roof required cutting of nearly a hectare of reed. In total, taking the average number of people working on the project, the construction of the shelter has taken 5 people approximately 30 days. The medieval wooden hut was built in the eastern part of the museum area. It was made in mixed saddle-nut and post and log construction. The building has dimensions of 4 by 6 meters at the base and 5.5 meters high. The walls were built from round pile pine logs on which a gable roof was arranged in a combined purlin structure with the ridge supported on a wooden oak floor. The entire structure, with the outbuilding, plays a role of carpentry, casting, and goldsmith workshops. Before the work began, a full carpentry workshop was purchased from the collection of one of the authors, and wooden semi-finished products were collected. Thanks to these activities, various copies of handrails, drills, planes, axes, chisels, saw adzes, and axes were obtained. Foundation grinding boulders were placed under the bottom logs in the corners of the hut. A flat limestone rock was positioned below the low-set beam. To connect the logs in the corner, saddle notch corner type of joint with precision was used. In the middle of the walls, vertical posts were inserted, in which the tie beams have been fitted with mortise and tenon joint. In the longer side walls, the vertical posts with grooves were used to connect the short logs. Wall seals between beams were made of forest mulch, mainly from moss. As a part of the experiment, it was decided to perform the most challenging stage of the work related to construction of the roof structure by only one person. It turned out that this is possible with the help of ropes and levers. The roof cover was arranged from planks in accordance with the slope of the roof. The roofing with overhangs was created from overlapping spruce lever planks, which were pegged to the roof structure. The roof ridge was equipped on the one of its ends with so-called szparogi, a wooden decoration in the form of crossed spears. The main idea of the hut builders was the willingness to deal with as many different processing techniques as possible, and a large set of materials. Here you can see the final result. The building has mostly earthen floor, although there is a part of the entrance that was made of leftovers of oak piles. The hut also has an open attic with a lumber floor. A pear-shaped stone clay stove with a smoke hole in the top was made for the purpose of heating the building. Ventilation, similar to a chimneyless hut, smoky hut, is provided by open gable tops, additionally equipped with curtains made of sheep leather, which allow for covering the clearances depending on the wind direction. The whole hut construction was carried out with a time frame about 5 months. The inspiration and starting point for the construction of the shallow pit house built by members of the Society for Prehistoric Experimental Archaeology were buildings from Finno-Scandinavia called glahti. A glahti is a hut or tent that could have 3 types of covering: fabric, peat moss, or timber. The tough version of glahti have the structure covered with birch bark and peat to provide durable construction. They are permanent or shelter structures built by Sami people probably from the Stone Age to the modern times. There are many sites from Scandinavia where the remains of buildings interpreted by research as structures of this type were discovered. In our case, we decided to build a semi-underground structure. During the construction of the shallow pit house, many experiments related to wood processing were made. During the works, replicas of experimental tools were used, such as flint axes, wood spliners made of bone and antler, planes with flint inserts, and planes made of antler. However, this building is not a fully experimental reconstruction, because during the works, due to the limited time, it was necessary to use modern tools. First stage, a regular pit with straight walls was dug. Then every few dozen centimeters, pine pegs were dug in. The next step was to wave the walls with willow twigs. The walls made in this way were covered from the inside of the future building with a mixture of clay, sand, grass, and water. Then the soil was poured into the empty spaces between the trench wall and the building wall. After that, we built the stairs using split pine planks and willow twigs. For the construction of the roof, it was originally intended to use two arches made of naturally bent tree trunks, just like in the original Gati, but due to the lack of such material, a simple framework was made of pine beams, which was then covered with wood beams. The next step was to cover the roof of the building with birch bark patches that act as an insulator. In the case of the walls, due to the insufficient amount of this material, a reed layer was used. After that, the cubes of soil with turf were placed on the prepared surface of the roof and walls. Building, a stone heart was placed in its central point. After the first fire test, to improve silkuration, raw deer skins were attached to the chimney opening. The walls inside the building were whitewashed with a layer of chalk mixed with water. The paintings on the wall were made by using a mixture of red ochre and water. These are representations inspired by the wreaths from the archaeological site in Alta in Norway. They present images of reindeers, elks, waterflow, fish, human figures in scenes of hunting, swimming on boats, etc. Opposite the entrance, we made a totem made of elk skin and a deer skull with antler. You can see the final result of our work. We called our shallow pit house the Shaman's House. Nowadays, the Open Air Museum is a base for different activities, such as various students' classes, like, for example, experimental archaeology course. Students have opportunity to learn methodological foundations of experimental archaeology and critical analysis of the experiments. They are also planning, preparing, and conducting their own experimental programs based on their interests and individual research plans. Each of the planned experiments carried out individually or in groups is discussed and reviewed publicly. Experiments are usually based on the latest archaeological discoveries or the results of interdisciplinary research. From 2018, we are publishing the results of some of these works in our newsletter called Experimental Archaeology in Nicolaus Copernicus University. You can find our newsletter on two platforms, researchgate.net and academia.edu. Open Air Museum has become not only a space for experimental research, but also a place used to promote archaeology. On its area, workshops, lectures, shows, and museum lessons are organized. Regular events such as Festival of Science and Art are also conducted here. This place gives us an excellent space to share the knowledge about the human past in the way that is accessible for the people who are not related to archaeology. The Open Air Museum is also used during scientific conferences and also by the members of the staff of archaeology during different activities like picnics. We know that for many of you, our projects and the Open Air Museum maybe look small, but for us, it's something big. Its construction was a great challenge, but also a great fun and pleasure. We hope that these buildings will serve us for many years, and this place will be inspiration for next experimental works that will be conducted at the Institute of Archaeology Nicolaus Copernicus University. Thank you very much for your attention. We hope that you enjoyed this presentation. If you have any comments, questions, or suggestions, please feel free to write us an email. Once again, thank you very much. Bye.